Right, here we've got a Bose Lifestyle 20 music system, and it's old, it's lovely, but it's well loved by its owner, and we've just fitted a new ejection gear motor assembly, which I sell as a part. So when the gear comes off this shaft, and we've got a new one with a nice metal gear, a really high quality Japanese version of it. But anyway, that's been fixed on that side. If you want to see that, look in the other video. But this one is all about the display, the vacuum fluorescent display. Now, there's another video that shows you, you can see I'm just doctoring this here to check these capacitors. There's a AC input to the unit. There's an AC voltage dropping network with capacitors and diodes and things, voltage doubling, to get the right potential on the grid, the cathode and the anode, to make the electrons fly up and hit the anode, which is covered in a fluorescent material which makes this glow. Now, what happens is these capacitors get old, and they're not very happy where they are. It's not a great design because they're just insufficiently high quality, or they're of insufficient quality, the components, and they don't like being used in that kind of situation. And for example, the heater current for the cathode, there's obviously some heat's got to go through to get the thermionic emission levels up, so there's tiny little wires in there which are running hot, and when they're running you've got about 3.5 volts AC, about RMS, about 3.4 volts AC across there is typical for most VFD displays. Now what happens is these capacitors age, and as it ages over years it gets dimmer and dimmer and dimmer, and I'm not sure if it's the aging process that denigrates the cathode emission, or whether the cathode emission is oxidizing and getting less effective because of this problem with these capacitors, or as well as. So I'm not sure if it's an either or situation, but some people have said if you repair the caps, which I've done here, and there was no display when I got it, but now if I turn it on now you can see everything all clear. There you go, it's come on. And you can't even see that, can you? It should be a deal brighter. Okay, we've got studio lights on here, or desk lights, or if I turn all this off. Did you see that then? Did you see that? If I just go into spot meter and we choose it there, you can see it now, can't you? That says 107.9, right? The voltages are correct. I've got -30 on the anode, -24 on the grid, and about 0 relative to each other, not relative to 0 volts on here. You have to be careful because these things are floating about at strange potentials. Not relative, it's AC coupled, and so the whole thing is at a different potential than the 0 volts. So I'm talking about relative to each other. You can see that's very dim. It looks bright to you, but honestly, if I just have normal lighting on, it's not good. Now if you come at this and you think, oh, that's a bit dim, I'm going to do what he did. Don't do what I'm going to do, because if you do what I'm going to do and you don't get it right, or it goes wrong, it may ruin the display. So before you do what I'm going to do this to check, to make sure that you need to do what I'm going to do, because if you don't need to do what I'm going to do and you do it wrong, then your display will be ruined. Okay, so there's an element of risk what I'm going to do next, and you have to hang on every syllable and do what I do. Otherwise, if you don't do what I did, then you might end up with a bricked display and you can't use it anymore. So this is a green filter window. Nah, you can't really see that, can you? Have I got something I can show you that with? Right, okay, so this is the window, and this is a filter, and you can see, it's actually not very clear, is it? It's kind of a brown filter. There's several wavelengths of light. It's actually green, but these are just I'd expect that to be a green filter. That's not going to improve the contrast very much of that display when it gets dim. Normally this would be a dark green filter window, and I'll just demonstrate that for you. Hold on a minute. I'm just going to demonstrate to you why Bose have used the wrong colour. Stupid buggers. Those Bose boys, they should phone me and ask me to appraise every product they make, to stop them making stupid cock-ups, which is what they've done at the moment. Oh, we don't mind. I'm not going to ask that magic smoke fella, because we know what we're doing. I've had 4 years in college and 3 years experience, and I know what I'm doing. Oh, that's nice. If I can find the right one. Nope. You've seen this box, this back, these are really useful bits of kit, these. I'll just turn the light on so you can see proper. Turn that on to auto so you can see proper. It's a filter book from Lee Filters, and it's got everything in here. It's got infrared filters, it's got half morning frost filters, and these are the photographic industry uses these. And if I can just find one which might work on this display. Clearly red and green don't really work at all. That's the brown one they've got there, more or less. That's not bad. Turn the light off again in a second. Just let me sort through these filters. Yeah, there you go then. So I found one. It's a close enough for jazz. I'm sure there's about one in here. But you can see that this one, that's the band pass and the optical wavelengths of the filter. Whiz it around there out of the way. You can see basically it passes around the 500 nanometers, which is kind of blue-green, and also above 800, which is unusual, which is getting up. Oh, sorry, that's infrared, so it lets the infrared through as well. Right now, so that's the bandpass, that filter. So I'll just show you what they've done. And the transmission, that's the transmission. So we've got 8. I'll just show you what Bose have got on there. Look, can you see that? Can you even see that? I'm not going to adjust anything. You can just about see it vaguely through the haze, can't you? Well, look what it looks like with the proper filter on. So for a start, they've had to drive that harder than they should have done just to get the thing working, but it's much better with my filter than their shitty one, because they put a brown grey one and it's just to improve the contrast, whereas this is actually tuned to the frequency of the light that's coming out of it, and you get a much better thing. But can you see that? What does it say there? Zone 1. It's hardly fluorescing at all, but the voltages are correct on this display. Yeah, so that's what we got at the moment, which is not good. Now down the front of this thing, if I just turn the power off and turn the lights on and then press that button there into auto mode, we're all back to square one. And what we've got on this is power is off, that's correct. And you can see under here, if I just prop that up with a little box. You can use any kind of box, not a special box. Right. Box. I think I'm going to have to turn this upside down, aren't I, for you to see this? I think you are. I am. Right, so let's turn it over. Let's turn her over. There's the display, alright. On the top side of the display, that's what you can see. Now on the bottom side of the display, I can just do this without bollocksing something up. Power out for the moment, so we don't need power. Take that over to there, so we don't need that. Right, so what we've got underneath is all the connections for this vacuum fluorescent display, which are made by Itron in Taiwan, were the masters of this display. You can see you've got this row of pins here, look. Right, now if you measure, if you've got no display action at all, even though you've checked those capacitors and the power supply as detailed in the other video, have a look at this. Have a look at this, Nora, and put that there, and you can't see that either. This is bloody ridiculous. Not doing very well today, are we? There we are. There you go. So we're on ohmage at the moment. So we're reading 0.4, and that's my leads, I think, and the offset. Good meter this. This is my third one. Right. Okay. So you can see these end connections. These two are common because they go down to the same bracket down there, and if we go between there and there, you can see the heater wires. 6.8 ohms of heater wires. Now, the current is actually pretty low in those heater wires because when they heat up, the resistance will go a lot. So they're tiniest, finest wires. And so we've got 3.4 volts. So the startup current is going to be about 500 milliamps, isn't it? 2.8 volts, 2.7 volts, about 400 milliamps or something like that. And then as it heats up, the resistance, the element will increase, the cathode heater, and the current will go down. Now, I've never done this on a Bose before, but I've done it on HP test equipment. In fact, my 8903B over there on the shelf, the audio analyzer, has had this done on it. And because it was so dim and it was no usable, but it's actually rejuvenated it. I think it had been switched on in a production rack for a long time because I turn it on, use it, turn it off. I'm not particularly careful about turning it off, but it seems to last a long time actually. So like, that's about 5 or 6 years ago and it's still going strong. So between these two, you've got the heater voltages, and normally percent transmittance at 500 nanometers and 2.5 to 3.5 volts RMS, and it's normally AC. Now, the other thing you should bear in mind is that on many displays, this seems to be a kind of a, I suppose you'd call it a back bombarded or a backlit display, because on many of them, you can actually see the heater wires on the surface. If I just take this plastic thing off, I think I stuck it with double-sided tape. I did. Take this, it's just a dust screen, because they're got voltages on them, they do attract the dust, so they have this plastic screen, which is, I don't know if that acts as a dust screen, but there's the front of the display. Let's give that a clean, give it a bit of a polish. Right, have I got another one I can show you? I don't know if I've got one. But normally with this, you would, if I zoom right in and get as far as we can get in, let's go into zoomy mode. Right, so we can see this display, and now I'm just going to connect it up. So I think I can use these leads. I can turn that off because I don't need that on. I can put those onto there. No, I can't because they're different. Yes, I can. That goes on there. Right, okay, so now what have we got? We've got on these two croc clips, these two croc clips are connected to, so there's the unit, all looking lovely. There's my meter that you just saw, there's my filter book you just saw. Now down here we have a variac, and it's turned off. There's a main switch on there for turning the equipment, the unit under test, on and off, right? So you can turn the voltage up and down like that, so you can go up to 280 and all the way down to 100. So I've got full control of my AC input voltage. And that box there is the breakout box for my power meter, so I can always put the power meter on. There's got two power meters, they've got a 110 and a 210, all right? So I can tell what power is being consumed and the phase angle and everything else, everything I test, all right? So there we go. Then I've got my power supply, which is DC, and I've got my electronic load, and I've got my precision signal generator over there, which is an audio one, and so on and so on. But under here, look, you've got the variac. I can go 110, 120. I can mess about with the power and see if I can upset the power supply, cause things to blow up. I can have wires dangling down all over the shop, which sort out on things and cause me even more trouble. Plug socket on the side because it had a shitty Chinese plug on it when I got it. But it's a good variac, 8 amp or 10 amp. Then the breakout box there. This is a clean power clean AC from the AC power generator, so I can do step functions and sinusoidal and triangular, and then do brownouts and testing of power supply designs. That goes over to a big box, big heavy AC generator over the side. It goes up to 400 hertz. Then from there you go to here. This is one of those boxes. Do you ever went to school? They threw the load of these out from the school. They're in the skip, and I went to pick up my kids. And there's about a dozen of these from the lab, and they're just an AC transformer box with a switch on the front, so you can go from 2 to 12 volts. Mains power, and then you've got AC output here, depending on the selection of this switch. An overload reset button, so when your electric motor during your physics experiment shorts out, it goes ping rather than causing a smoking adventure. DC output, which is just rough rectified, bridge rectified DC. So, and then what I've got is two of those. So I've got that one there, which then feeds out of this one here, and normally goes into this plug over here, and the AC out from this goes through that light bulb if I need it, just in case I want to turn on a power supply I've just repaired, and then through. So the power that's coming out of the main system is isolated, so you've got no copper connection between the power on this side, mains reference power, or neutral's reference to earth or the supply ground, goes through that transformer out through 12 volt transformer at 5 amps 60 watts into the output of, well, what would normally be the secondary of this transformer, and the primary of that transformer is then driving my equipment. So it gives me quite a high impedance main supply, which if I short something out, there's no smoke and drama. There's just a loud buzzing from these boxes, and if I persist in the shortage situation, you hear a buzzing and then the reset button pops out. So at the moment I'm going to run from here basically, which is my AC out. So by turning that up and down, turning my variac up and down, I can get isolated AC, and I can heat this up and I can hopefully see a glow going on. So let's just try that. So I need to clip my wires onto there and then clip onto here, then connect my meter so I can check what voltage I'm putting in to make sure I'm not overdriving them. Well, how much I'm overdriving. The whole plan is to overdrive them. Stupid boy. And we'll see how it goes from there. Hold on a minute. The AC output of my first box, so it's mains isolated. The variac is feeding the primary of that box, therefore I can turn the voltage up and down on these crop clips. The secondary is set to 12 volts. I'm going to set it to, actually I'll leave it on 12. It's set to 12 volts AC, so if I put 110 volts in, I'll get roughly 6 volts and so on and so on. So I can turn it up and down and measure the voltage. So I'm going to clip onto the heating wires. I would do if someone hadn't stepped on my clip. I'm going to clip this onto the heater wires, which is there and there. Nothing else connected, no reference to ground. There's nothing connected to this unit apart from these two clips at the moment. So I'm connected across the heaters, and I know it's safe to supply 3.5 volts, but I'm not sure what's going to happen with this when I go above 3.5 volts, and I can't run it to see whether the brightness is coming back. Other people say you heat the wires up until they get red hot, others say white hot, but as I say before, I could see on the other ones you can see the cathode wires. Now I don't know if can you see them if you bend that up? Can you see them from underneath, do you reckon? They can't bend it up anyway. So I think what we're going to need to do is to put the blinds down in the room. So I'm going to turn the power on. The variac is turned right down. I'm going to start feeding 12 volts in. Right, 1 volt, 1.8, 3 volts. We've got 30 volts going in on the AC side. 3 volts. 3.3, so that's about the running temperature, nothing at all. Ready? I'm going to go up to 4 volts. 4.4. There you go. You can see that red. That was 5 volts. Can you see the red? This time I'm going to go up there and just give it a quick blip. There you go. 2 of those. Right, there it is now. You can see it in the daylight. Look, it's just to remove the screens off here. Oh, ow. So that, I think, has made a bit of a difference. Yeah. Still a bit dim down this end, but I'm not going to give it any more than that because I just don't think I think it's usable now, whereas before it was pretty bloody dim, to be honest. Yeah. So, improved it. Has it got back to standard? No, but it's usable now, and I'm leaving it at that because I don't want to go any further. But it's not fantastic, but that'll have to do. Yeah, I hope you found that interesting. Leave me a like if you can. Go down the corner of the screen down here to the titty button and hit the subscribe button if you're not already subscribed. And thanks for watching. I hope you wouldn't find that too disjointed, but it was a real-time experiment. Never done it on this before, but it seemed to have worked. So thanks very much. Take care, and good luck if you're doing yours.